Alright guys, so let's do question number 3. Okay, so we have f of x is equal to x squared over x squared plus x minus 3. Alright guys, so here this function is a rational function, of course, so we're going to find the vertical asymptote. Alright, vertical asymptote. Okay, so we're going to say let x squared plus x minus 3 be equal to 0. Now notice guys, here this question doesn't have factors. Okay, so you're going to introduce a quadratic equation formula. Okay, now x will be equal to, what is our b? Our b is 1, so we're going to have negative 1 plus or minus the square root of 1 squared minus 4a negative 3 over 2 1. So our x will be negative 1 plus or minus the square root of 1 plus 12 over 2. So our x will be negative 1 plus or minus the square root of 13 over 2. So our x will be negative 1 plus the square root of 13 over 2, or x is equal to negative 1 minus the square root of 13 over 2. So now guys, here's the thing. What is the square root of 13? Approximation. Square root of 13 is 3 point something. Alright, now notice x will be equal to, you don't have to write this in your answer sheet. This is just for you to know, right? So notice guys, so negative 1 plus 3 point something, right, over 2. This is same as 2 point something, right, over 2, isn't it? Now 2 point something over 2 is the same as 1 point something. Okay, that would be our vertical asymptote, will be 1 point something. Now notice this one, we're having x equal to negative 1 minus the square root of 13 over 2. So this is the same as negative 1 minus 3 point something, of course, over 2. This is negative 4 point something over 2. And this one will be negative 2 point what something, isn't it? I want you to keep this in mind. This one is 1 point something, this one is negative 2 point something. Okay, so I'll erase this. So these two are my vertical asymptotes, this one and this one. Now let's find the horizontal asymptote. Now for the horizontal asymptote, remember, since the powers are the same, our HA will be limit as x approaches infinity of x squared over x squared plus x minus 3. So now here's the thing, I'll factorize the highest power on top, which is x squared, and I'll remain with 1 when I factorize. Even down here, I'll factorize the highest power. I'll remain with 1 plus 1 over x minus 3 over x squared. When factorizing, it's like you're dividing, right? So when you factorize x squared, it's like you're dividing x squared divided by x squared. Now guys, notice immediately this cancels out. The limit will also disappear, but it will leave infinity where there is x. So I'm going to have 1 over 1 plus 1 over infinity minus 3 over infinity squared. So this will be 1 over 1 plus 0 minus 0, and this will be 1 over 1, which is 1. Okay, now here's the thing guys. When the denominator is of a greater power of x than the numerator, like this, when you see this is greater power than this, the horizontal asymptote is always 0. But you have to prove the way I've been proving. And if you see that the denominator and the numerator have got the same powers of x, like these powers here, have you noticed? Meaning, for you to have the horizontal asymptote, you're just going to divide the coefficients of the greater powers. So this will be what? 1 over 2. So if you add this, 3x cubed over x cubed minus 1, okay, plus 2, right? What would be horizontal asymptote? Since these have got the same powers, your horizontal asymptote will be just divide the coefficients. So this will be 3 over 1, and the answer will be 3. Okay? You can even check it from our question. Let's check it from our question. Let's view it from our question. Notice here, we had x squared and x squared. Just divide 1 divided by 1. That's it. 1 divided by 1 is 1. But you have to show the option though. So now guys, after you have this, you have to sketch. Now this is 0, of course, this is y, and this is x. So that one was negative 2 point something. So this is negative 1 minus the square root of 13 over 2, this point. Then this point here, which is 1 point something. Now guys, 1 point something is above 1, right? But before 2. Then the horizontal asymptote was 1. This point here is 1. Okay, so how many regions do we have here? We have 2 regions. We have 3 regions. We have the region here, we have a region in between, and we have a region after. So we're going to create tables for this. So I'll create tables for the values before this. So my function, remember, is x squared over x squared plus x minus 3. Okay, so I'll create 4 points, x, y, 1, 2, 3, 4 points. Okay, so I'll pick values before. Now notice this is negative 2 point something, so I'll pick negative 3, negative 4, negative 5, negative 6. So I'll start replacing. When I replace negative 3 there, negative 3 squared over negative 3 squared plus negative 3 minus 3. This will be 9 over 9 minus 3 minus 3. And the answer will be 9 over 3, which is 3. Okay, I'll replace negative 4. So if I replace negative 4, I'm going to have positive 16 over 16 minus 4 minus 3. This will be 16 over 12. This is 12 minus 3 over 9, so this will be 16 over 9. Okay, when I replace 5, this will be 25 over 25 minus 5 minus 3. This will be 25 over 17. Okay, yeah, if I replace 6, this will be 36 over 36 minus 6 minus 3. This will be 36 over 27. Okay, now 36 over 27 is just 1 point something. Don't be threatened. Now let me pick values of x in between. So I'll pick values of x which are in between here. What values of x can I find in between here? Notice this one is negative 2 point something, right? Negative 2 point something. So 2 point something is greater than 2, isn't it? So I'll pick negative 2, negative 1, 0, and 1, because this is 1 point something. So I'll pick negative 2, negative 1, 0, and 1. These are the values that are in between. So if I replace there, negative 2 squared is 4 over 4 minus 2 minus 3. So this would be 4 over 2 minus 3. This is negative 4. Okay, negative 4. Then I'll pick 1, negative 1. So this will be 1 squared. Negative 1 squared is 1. This will be 1 minus 1 minus 3. So it is negative 1 over 3. I'll pick 0, and I pick 0, it will just be 0. I'll pick 1 over 1 plus 1 minus 3. This is 1 over negative 1. Okay, so now I need to pick after the vertical. Notice I'm picking before the vertical asymptotes. I'm picking here, here, and here. The vertical asymptote creates regions. So I'm left now with region 3, x, y. I'll pick after, so I'll pick 2, 3, 4, and 5. I'll pick this side. Okay, so if I replace 2 there, it's gonna be 4. So 2 there is gonna be 4 over 4 plus 2 minus 3. So this will be 4 over 6 minus 3, which is 4 over 3. 4 over 3. Then I'll pick 3. Now 3 will be 9. 9 plus 3 minus 3 to be 1. Okay, I'll pick 4. 4 will be 16 over 16 plus 4 minus 3. This will be 16 over 17. And I'll pick 5. It will be 25 over 25 plus 5 minus 3. So it will be 25 over 27. Okay, now guys, let's sketch these. All right, so let me start with the first one, negative 3 comma 3. So this is negative 2 point something, right? So I'll say this here is negative 3, negative 4, negative 5, and negative 6. Notice the lowest value of x is negative 6. Have you noticed? Then the highest is 5. So this is 1 here. Okay, then this is 2, this is 3, 4, and 5. 1, 2, 3, 4, and 5, of course. This is negative 1, negative 2, negative 3, and negative 4. So I'll start negative 3 comma 3. This is negative 3 comma 3 somewhere at this point. Then we go to negative 4. Now guys, 16 over 9 is 1 point something. So negative 4 comma 1 point something is somewhere here. Now 25 over 17 is still 1 point something. So 5 comma 1 point something. Now 26, is it 36? Yeah, 36 over 27. 36 over 26 is still 1 point something. So it will just be above 1 here, right? So notice it will follow this vertical asymptote like that and follow the horizontal. Now let's sketch in between. Negative 2 comma negative 4. This is negative 2. This is, sorry. So this was negative 2 point something. So meaning negative 1 is here. Then negative 2 is here. Okay, so negative 2 comma negative 4 is this point. Then negative 1 comma 1 over 3, guys, is 0 point something, right? So it will be somewhere here. Then 0 comma 0 is here. Then 1 comma negative 1, it's somewhere here. Notice how it's going. It will follow this, to follow this, and it will follow this, and it will follow that. That's how this graph is. Now let's sketch after. 2 comma 4 over 3. 4 over 3 is 1 point something. So 2 comma 4 over 3. 4 over 3 is 1 point something here. Then 3 comma 1. Okay, 3 comma 1, it's here at this point. Then 4 comma 16 over 17. Now 17 is down here, right? So it will be 0 point something. It will be this point. Even this one will be 0 point something. So notice this one will come from there and go and cross like that. This is a graph, guys. So now I'll repeat. The graph cannot cross your vertical asymptote. It can't. Impossible. But at special occasions, like this question, it can cross the horizontal asymptote. It can cross. Okay? At special occasions only. But in most cases, it doesn't. But at special occasions, it does. But for this one, for the vertical asymptote, no go error, guys. No go error. So that's how you answer this question. And let's try solving the other questions.